Welcome to the Sleepy Mind channel. Today we are going to explore the moon and its phases. The moon has always been present in the night sky, steady enough to feel familiar, yet distant enough to remain separate from daily life. It appears without effort, following a path changes slowly from night to night, long before it was measured or explained. It was noticed simply because it returned again and again, in a form was similar but never quite the same. What appears to change is not the moon itself, but the way its surface is lit and revealed. At any moment, half of the moon is illuminated by the sun. This is always true, regardless of how much of light is visible from Earth. The changing shapes appear across the month are the result of shifting angles rather than shadows. The moon moves through space while Earth turns beneath it. Sunlight strikes its surface from a steady direction. What changes is the portion of illuminated surface faces Earth. Because of this geometry, the moon does not repeat itself from one night to the next. It rises later each evening, drifting eastward in its orbit while Earth continues its rotation. On average, the moon rises about 50 minutes later each day, over the course of a month. This gradual shift carries it through every hour of the night, even at its brightest. The moon is rarely seen as completely full, the moment of exact alignment, when the entire sunlit face would be directed toward Earth, is brief and usually hidden by the conditions create a lunar eclipse. Most full moons are slightly incomplete, though the difference is too small to notice without instruments. The idea of fullness is therefore an approximation shaped by human perception rather than precise geometry. Although the moon keeps the same side facing Earth, it does not do so perfectly. Small variations in its orbit and rotation create a gentle rocking motion. Over time, this movement allows additional portions of the surface to come into view. When these shifts are added together, more than half of the moon's surface becomes visible from Earth across many months. The moon appears fixed, yet it is never entirely still. Its path through space is not aligned perfectly with Earth's orbit around the Sun. The moon travels along a tilted plane, inclined just enough to prevent regular alignments. Because of this tilt, eclipses do not occur every month. They appear only during narrow windows when the geometry briefly aligns. Their rarity is not accidental, but the result of stable imbalance. The relationship between the moon and Earth extends beyond light and appearance. Their gravitational connection is constant and measurable. As the moon orbits, it pulls gently on Earth, contributing to subtle changes in rotation and motion. Over long periods of time, this interaction has helped to steady Earth's orientation in space. Without the moon, Earth's axial tilt would be far less stable. Seasonal patterns could shift far more dramatically. Despite its brightness, the moon produces no light of its own. Its surface reflects sunlight, scattering it back toward Earth. The reflectivity of the lunar surface is lower than many people expect. The moon appears bright only because it is close and because it stands alone in a dark sky. When compared directly, its surface reflects less light than fresh snow or pale desert sand. Near the horizon, the moon often appears larger than it does overhead. This change is not physical. The moon's size in the sky remains almost constant. The effect is created by perception, shaped by nearby objects and familiar distances. When the moon rises among trees, buildings, or hills, it is compared to known scales. High above, without reference points, it appears smaller, even though nothing has changed. The far side of the moon receives the same amount of sunlight as the near side. It experiences day and night just as regularly, though those days and nights are long. The idea of a permanently dark side emerged from limited observation rather than physical reality. What remained unseen for centuries was distance, not darkness. As the moon continues its orbit, the illuminated portion visible from Earth grows and shrinks in a steady sequence. This cycle takes just over 29 days to complete. It does not reset abruptly. Each phase blends into the next, forming a continuous progression rather than a series of separate states. The cycle has no beginning or end, only a moment when visibility is lowest, before light gradually returns. The timing of these phases is predictable. A new moon rises with the sun and sets with it, remaining hidden in daylight. A first quarter. Moon rises around midday and stands high at sunset. A full moon rises as the sun sets, crossing the sky through the night before fading in the morning. These patterns repeat with quiet reliability, providing a natural measure of time long before mechanical clocks existed. Although the moon's orbit is stable, its distance from Earth changes slightly along an elongated path. When the moon is closer, it appears marginally larger and brighter. When it is farther away, it appears smaller and dimmer. These differences are subtle, yet measurable. They show even familiar cycles contain variation. Over immense spans of time, the moon is slowly moving away from Earth. The change is gradual, measured in centimeters per year, but it accumulates. In the distant past, the moon appeared larger in the sky and completed its cycle more quickly. The rhythm observed today is the product of long adjustment rather than permanence. The moon's surface preserves this history. Without a substantial atmosphere, it does not erode or heal in the way Earth does. Impacts remain visible for billions of years. Dark plains mark ancient flows of molten rock, while lighter highlands record even older events. Each feature is a fragment of time, exposed and unchanged. For all of its complexity, the moon follows a simple set of rules. It moves according to gravity, reflects light according to its surface, changes appearance only because of alignment. These constraints give rise to patterns are easy to observe and slow to change. The moon does not react or adapt, it proceeds. This steadiness is what makes the moon such a reliable presence. Night after night, it returns in a form can be anticipated, even if it is not immediately recognized. Its phases mark time without urgency. Its motion requires no attention to continue. It remains present, not because it demands notice, but because it does not. From this foundation of motion, light, constraint, the moon's cycle unfolds. Each phase follows from the last, shaped by alignment rather than event. To understand the moon is to follow this sequence slowly, allowing each change to reveal itself in its own time. The moon did not arrive quietly into Earth's orbit from deep space. It formed from Earth's own material during a time when the planet itself was still unstable. Early in Earth's history, while its surface was hot and its interior was still organizing, a collision occurred. A body roughly the size of Mars struck the young Earth. The impact was immense, but it did not scatter everything beyond reach. Much of the material thrown outward remained close enough to be held by gravity. Over time, this debris began to gather. Fragments collided, slowed, merged. What remained eventually settled into a single body, orbiting Earth. The moon formed, not through slow growth, but through reassembly after disruption. This origin helps explain the Moon's composition. It shares similarities with Earth's outer layers, yet lacks the dense metallic core, gives Earth much of its internal heat and magnetic strength. The Moon carries the chemical signature of its beginning, shaped by separation rather than independent formation. Once established, the Moon entered a narrow balance. It is large enough to exert influence, yet not large enough to dominate. Earth's gravity holds it securely, preventing escape, while distance prevents collapse. Its orbit is stable, changing only gradually across vast spans of time. Distance plays a quiet but decisive role. At roughly 380,000 kilometers away, the Moon is close by astronomical standards. That closeness allows its gravity to reach Earth's oceans and influence Earth's rotation. At the same time, the distance keeps the Moon visually small, a steady disk rather than an overwhelming presence. The Moon's size also sets firm limits. At about 1/4 Earth's diameter, it has enough gravity to shape itself into a sphere. It does not have enough to hold a thick atmosphere. Gases escape easily, drifting away rather than remaining bound. Without an atmosphere, the Moon cannot trap heat or circulate energy. As a result, temperatures shift sharply. When sunlight reaches the surface, heat builds quickly. When darkness arrives, heat escapes just as quickly. There is no wind to move warmth, no clouds to soften the transition. Day and night arrive without warning and leave without delay. Sound cannot travel across the lunar surface. There is no air to carry it. There is no weather to reshape the landscape. Rain does not fall. Wind does not erode. What happens on the Moon tends to remain visible, not because it is protected, but because there is nothing present to remove it. Gravity on the Moon is weaker than on Earth. Objects weigh less and fall more slowly. Movements stretch out. Once something is in motion, it travels farther before returning to the surface. This affects how dust settles and how debris spreads during impacts. Craters grow wider than they are deep. Material thrown outward travels long distances before settling. Over time, these patterns accumulate, recording events rather than smoothing them away. The surface becomes a record rather than a cycle. Large basins mark ancient impacts from a time when collisions were more common. Dark plains formed later, when molten material rose and filled low areas before cooling. These regions remain visible today, contrasting with the brighter highlands around them. Time itself feels different on the Moon. A single day lasts about 2 Earth weeks, followed by a night of similar length. Sunlight lingers, darkness lingers. Each transition unfolds slowly, shaped by rotation rather than atmosphere. This slow rhythm contributes to the Moon's predictability. Its position can be calculated far into the future. Its phases repeat with steady regularity. Its surface changes only when struck by something new. Despite its stillness, the Moon is not disconnected. Its gravity interacts continuously with Earth. Tidal forces stretch both bodies, though the effects are more visible on Earth. As oceans rise and fall, energy is lost over long periods. This loss slows Earth's rotation slightly and pushes the Moon outward. The outward drift is small, measured in centimeters per year, but it accumulates. In the distant past, the Moon appeared larger and moved through its phases more quickly. What is seen today is not permanent. but a moment within a much longer process. The moon does not adjust or respond. It follows, bound by mass, distance, gravity. It moves according to rules change very slowly. This lack of flexibility is what makes its behavior reliable. These constraints form the foundation for everything follows. The phases, the timing, the influence of the moon all emerge from this fixed relationship, with its origin established and its limits set. The next layer of understanding comes from motion itself. Once the moon settled into orbit, motion became its defining feature. Not movement in the everyday sense of speed or change, but steady travel governed by gravity. The moon does not wander. It follows a path shaped by Earth's mass, moving forward, even as it is continuously pulled inward. The moon travels around Earth roughly once every 27 days. This motion is smooth and persistent. It does not pause or reset. While Earth turns beneath it, the moon continues along its orbit, shifting its position against the background of stars. This slow movement is the reason the moon appears in a different place each night, even when its shape looks similar. At the same time, the moon rotates. This rotation is not separate from its orbit. Early in its history, the moon likely spun more quickly. Over time, Earth's gravity acted unevenly on its mass. This created friction within the moon itself, gradually slowing its rotation until it matched the pace of its orbit. The result is a state known as tidal locking. Because of this balance, the moon completes one rotation on its axis in the same amount of time it takes to complete one orbit around Earth. As a result, the same hemisphere always faces Earth. This does not mean the moon is motionless. It is rotating constantly. The rotation simply keeps pace with its orbital movement. This locked orientation gives the impression of stillness. From Earth, familiar patterns on the moon appear fixed. Large, dark regions and bright highlands return night after night. Yet the moon is turning through space all the while, presenting different faces to the sun as it travels along its path. The orbit itself is not a perfect circle. It is slightly elongated. As the moon moves along this path, its distance from Earth changes. At its closest point, it is several tens of thousands of kilometers nearer than at its farthest point. These changes occur gradually and repeat with each orbit. When the moon is closer, its apparent size increases slightly. When it is farther away, it appears smaller. These differences are subtle to the eye, but they affect brightness and timing. The moon moves a little faster when closer and a little slower when farther away. Following the same rules govern planetary motion throughout the solar system. The moon's orbit is also tilted. It does not travel along the same plane. Earth follows around the sun. The tilt is modest, but it has important consequences. Because of it, the moon usually passes above or below the line would produce perfect alignment with the sun and Earth. This tilt is why eclipses are uncommon. Even though the moon passes between Earth and the sun once each month, Earth passes between the sun and moon once each month. The alignment is usually offset, only during brief periods. When the tilt lines up just right, do eclipses occur? As the moon moves across the sky, its path is shaped by both its orbit and Earth's rotation, rising in the east and setting in the west. It follows a curved arc, changes with latitude and season. Sometimes it climbs high overhead, other times it stays low, skimming the horizon. These changes are predictable. They follow patterns repeat over weeks and months. Observers who watch regularly begin to recognize them. The moon is not random in its motion. It is consistent, but complex enough to reward attention. Because the moon moves eastward in its orbit, Earth must rotate slightly longer each day for the moon to appear in the same position in the sky. This is why the moon rises later each night. The delay is noticeable. Over several days, the difference becomes obvious. This gradual shift affects how the moon is experienced. Some nights it appears early, visible before sunset. Other nights it rises deep into darkness or near dawn. Over the course of a month, it occupies every part of the night. The moon's slow pace also shapes the length of its day. One full rotation relative to the sun takes about 29.5 Earth days. This means sunlight remains on one side of the moon for roughly 2 weeks before giving way to darkness for another 2 weeks. This long exposure influences surface temperatures. Sunlit regions heat steadily, while shadowed regions cool deeply, without atmosphere to spread heat. These conditions remain stark. Motion determines not only position, but environment. Despite this, the moon's motion is remarkably stable. Its orbit changes only slowly. Small variations accumulate over long periods, but the overall pattern remains intact. The moon does not drift unpredictably. It follows a path shaped early and maintained through constant gravitational interaction. Earth is not the only influence. The sun also exerts a pull on the moon, tugging gently as the moon orbits Earth. This influence causes subtle shifts in the orbit, stretching and compressing it slightly over time. These changes contribute to longer cycles unfold across many years. The combined influence of Earth and Sun creates a layered motion. The moon orbits Earth. Earth orbits the Sun. Together, they move through space as part of a larger system. The moon's path is therefore not a simple loop, but a rolling curve carried forward through the solar system, yet from Earth. This complexity resolves into a familiar rhythm. The moon rises, it moves across the sky, it sets. The pattern repeats, altered slightly each time by position, phase, season. Motion becomes experience. This steady movement provides the framework for everything follows. The phases of the moon are not separate events. They are the visible result of this ongoing motion, shaped by orbit and rotation working together, before light and shadow can be traced across the lunar surface. The path carries the moon through space must be understood. Its motion is slow, constrained, dependable. From this movement, the changing appearance of the moon emerges naturally, with orbit and rotation established. The next layer of understanding comes from light itself. How sunlight reaches the moon, how it reflects. How reflection appears from Earth will shape what is seen night after night. Although the moon keeps the same face turned toward Earth, its presentation is not as fixed as it first appears. Small variations in its motion create gentle shifts, reveal slightly different portions of the surface over time. These movements are subtle, slow, easy to miss unless they are watched across weeks and months. This effect is known as libration. It occurs because the moon's orbit is not perfectly circular, and because its rotation speed remains constant, while its orbital speed changes. When the moon is closer to Earth, it moves slightly faster along its orbit. When it is farther away, it moves more slowly. The rotation does not adjust to match these changes. As a result, the moon appears to rock back and forth. There is also a side-to-side component. The moon's orbit is tilted relative to Earth's equator. as it moves north and south along this tilted path. Observers on Earth gain a changing view of the lunar poles over time. This allows glimpses beyond the edges appear fixed at first glance. When these motions are combined, they reveal more of the moon than expected, although only one hemisphere faces Earth at any given moment. The cumulative effect of libration allows observers to see about 59% of the moon's surface over time. The moon is locked, but not rigid. This slow revealing does not happen suddenly. It unfolds quietly, without drawing attention to itself. The moon's familiar markings seem steady, yet their exact positions shift slightly from one month to the next. The effect rewards patience rather than focus. Distance variation also plays a role in how the moon is experienced, as the moon moves along its elongated orbit. The time it takes to cross the sky changes subtly. When closer, it appears to move faster against the stars. When farther away, its motion slows. These differences are small, but they influence the rhythm of moonrise and moonset across the month. The changing distance affects brightness as well. A closer moon reflects more light toward Earth and appears slightly brighter. A more distant moon appears dimmer. These changes are gradual and often unnoticed, yet they contribute to the sense no two lunar cycles are exactly alike. Earth's rotation adds another layer. As Earth spins, it carries observers beneath the moon's path. The combined motion of Earth's rotation and the moon's orbit determines where and when the moon appears in the sky. Latitude matters. Season matters. The moon's arc changes throughout the year. At some times, the moon rises high and spends many hours above the horizon. At other times, it stays low, tracing a shallow path before setting. These differences affect how the moon is seen and how long it remains visible. They also influence how moonlight spreads across the landscape. The moon's motion is steady enough to be predicted far in advance. Its position can be calculated years or centuries ahead, yet for most of human history, this predictability was learned through observation rather than calculation. The moon became familiar because it behaved consistently. This consistency allowed early observers to notice patterns. They recognized the moon did not rise at the same time each night. They noticed its position against the stars shifted gradually. These observations formed the basis for early timekeeping, long before formal systems existed. The moon's motion also creates longer cycles extend beyond the familiar monthly rhythm. Over the course of years, the orientation of its orbit shifts slightly. The points where its tilted path crosses Earth's orbital plane move slowly. These changes influence when eclipses are possible and how frequently they occur. None of these motions are abrupt. They unfold over long periods, overlapping and interacting without interruption. The moon does not move in straight lines or sharp turns. Its path is smooth, continuous, shaped by multiple influences acting at once. Despite this complexity, the experience of watching the moon remains simple. It rises, it moves, it sets. The deeper mechanics operate quietly beneath this surface impression. Motion becomes something is felt rather than analyzed. The moon's slow movement also affects how it divides time, because it takes just over 29 days to return to the same position relative to the sun. The cycle of phases drifts slightly against the calendar month. This mismatch has required adjustment in every system, has tried to align lunar cycles with fixed dates. The moon does not fit neatly into human timekeeping. Its motion resists exact alignment with days and years. This resistance reflects the independence of celestial motion from human systems. The moon moves according to gravity, not convenience. As the moon continues along its path, it carries its illuminated surface through changing angles relative to Earth and Sun. These changing angles are the source of the moon's most familiar feature. The phases do not appear because the moon changes. They appear because motion alters what is visible. Before the phases can be followed, the relationship between motion and light must be clear. The moon does not switch states. It does not turn on or off. It moves. Light interacts with movement. Orbit and rotation establish the stage. Distance and tilt introduce variation. Earth's rotation shapes experience. Together, these elements create a system is both stable and dynamic. With motion fully established, attention can shift to how sunlight reaches the moon and how light is reflected back toward Earth. From this interaction, the changing appearance of the moon becomes visible, steady, predictable. The next step is not a change in movement, but a change in perspective. Light will reveal what motion has already set in place. Sunlight reaches the moon without interruption. There is no atmosphere to soften it or scatter it. Light travels through space and arrives directly at the surface, unchanged until it makes contact. What follows depends entirely on the ground it strikes. The moon does not create light, it reflects it. The surface sends sunlight back in many directions, rather than as a clean mirror. This scattered reflection is shaped by dust, fractured rock, uneven terrain. The moon appears bright, not because it reflects strongly, but because it is close and surrounded by darkness. In reality, the lunar surface is darker than it seems. Its reflectivity is low compared to snow, sand, or ice. If the same surface were seen in daylight beside Earth materials, it would look muted. At night, against a black sky, even a modest return of light stands out clearly. The texture of the surface matters. Fine dust coats much of the moon, created by countless impacts over time. This dust breaks light apart, softening its return. Moonlight spreads rather than shines. Shadows blur instead of cutting sharply. Edges feel gentle rather than defined. This gives moonlight a distinctive character. It brightens the landscape without overpowering it. Shapes become visible, but colors remain subdued. Movement seems slower, not because it is slower, but because the light encourages a quieter kind of attention. As the moon moves along its orbit, the angle of incoming sunlight changes. When light arrives from the side, it stretches shadows across the surface. Craters appear deeper, ridges stand out clearly. When light arrives more directly, shadows shorten and surface details seem to flatten. These changes happen even when the visible shape of the moon appears similar. A crescent lit from a shallow angle reveals depth and texture. A fuller moon, lit more directly, looks smoother and less detailed. The surface does not change. The angle does, without an atmosphere. These transitions are abrupt. Sunrise on the moon is sudden. Darkness arrives just as quickly when the sun sets. There is no gradual fading, no lingering glow. Light appears, remains steady, then disappears. Along the boundary between light and dark on the moon, shadows stretch far across the surface. This region reveals the most detail. Small changes in elevation become visible. From Earth, this effect appears as a shifting pattern of texture across the lunar face. Distance adds another quiet influence. As the moon moves closer to Earth, reflected light travels a shorter path and appears slightly brighter. as it moves farther away. The light spreads more and appears dimmer. These differences are small, but they contribute to the feeling each lunar cycle is slightly different. Earth's atmosphere alters moonlight further as light passes through air. Some wavelengths scatter more than others. When the moon is low in the sky, its light travels through more atmosphere. The result is a warmer color, often yellow or orange. As the moon rises higher, less atmosphere lies between it and the observer. The light appears cooler and whiter. The moon itself does not change color. The air reshapes what is seen. Brightness changes as well. Near the horizon, the moon may seem dimmer and larger. High overhead, it often appears brighter and smaller. These impressions come from perspective and filtering, not from physical change. Perception plays a role throughout. When the moon appears near familiar objects, its size feels exaggerated. Trees, buildings, hills provide scale. Without these references, the same moon seems reduced. Vision interprets context as much as light. Because moonlight is reflected rather than produced, it never overwhelms darkness. Night remains present. Details emerge slowly. Edges soften instead of sharpen. This balance allows the moon to illuminate without erasing shadow. This quality has made moonlight useful for centuries. It offers visibility without exposure. It allows movement without fully ending night. Landscapes remain recognizable, but still quiet. Across the lunar surface, reflectivity varies. Dark plains absorb more light and appear smoother. Brighter highlands scatter more and appear rougher. These contrasts form the patterns visible from Earth, especially when illumination is partial. As light moves across these regions, familiar shapes return. Dark areas stand out against brighter surroundings. These patterns have remained consistent, revealed again and again as angles repeat. What is seen from Earth is the result of several influences working together. Motion determines angle. Surface determines reflection. Earth's atmosphere shapes color and brightness. Vision interprets the result. Light itself remains constant. The sun illuminates half of the moon at all times. What changes is the portion of illuminated surface faces Earth. As the moon continues along its orbit, visible portion shifts gradually. Light reveals what motion has already arranged. From this steady interaction, the familiar progression of lunar phases becomes visible. The changing appearance of the moon is often described as if something is happening to it. In reality, the moon remains the same throughout its orbit. The surface does not switch states or cycle through conditions. What changes is the angle from its illuminated half is seen from Earth. At all times, one half of the moon is lit by the sun. This does not vary. Even when the moon appears dark, sunlight is still striking its surface. The apparent loss of light occurs only because the illuminated side is turned away from Earth. The phases are therefore a matter of position rather than transformation. This relationship depends on three bodies moving together. The sun provides light. The moon reflects it. Earth serves as the viewing point. As the moon travels along its orbit, the angle between these three shifts slowly. With each change in angle, a different portion of the lit surface becomes visible. When the moon lies between Earth and the sun, its illuminated side faces away from Earth. Little or none of light is seen. This is known as the new moon. The moon is present in the sky, but it blends into daylight and darkness alike. As the moon continues forward, a thin edge of the illuminated surface becomes visible. This sliver appears along one side, growing gradually night by night. The light does not arrive suddenly. It returns by degrees, following the moon's steady motion. This early stage of visibility reveals texture clearly. Low-angled sunlight creates long shadows across the surface. Small changes in elevation become pronounced, even though only a narrow portion is lit. Detail is rich. As days pass, more of the illuminated surface turns toward Earth. The visible portion increases smoothly. The moon does not add light. It simply presents more of what is already there. When the moon reaches a point where half of the illuminated side faces Earth, it appears divided evenly between light and dark. This is known as the first quarter. Despite the name, the moon is not one quarter lit. Half of the visible surface is illuminated. The term refers to position within the cycle, not to brightness. At this point, the moon rises around midday and is high in the sky by evening. Its position makes it easy to observe against a darkening sky. The line between light and shadow cuts across familiar surface features, revealing structure and depth. After this point, illumination continues to increase. The visible surface grows broader each night. Shadows shorten. The contrast between light and dark softens. The moon begins to appear rounder, though a portion still remains unlit. As the moon approaches the opposite side of Earth from the sun, the illuminated face turns more directly toward the observer. Eventually, the full sunlit hemisphere faces Earth. This is the full moon. At this stage, the moon rises as the sun sets. It crosses the sky through the night and sets near sunrise. Light reaches the surface almost straight on. Shadows are minimal. Surface texture appears flatter and more uniform. Although the moon appears complete, it is rarely seen as perfectly full. Exact alignment is brief. Slight angles remain. The difference is subtle, but it means even the full moon usually contains a narrow region of shadow. After the full moon, the visible illumination begins to decrease. The change follows the same steady pattern, but in reverse. A portion of the illuminated surface turns away from Earth. Light recedes gradually. This stage does not represent loss or fading. The moon continues to reflect the same sunlight. The geometry shifts. Visibility changes accordingly. As illumination decreases, shadows lengthen once again. Texture returns. The moon's surface becomes more detailed. Features seemed smooth under direct light regain depth as angles change. When half of the visible surface is once again illuminated, the moon reaches the last quarter. The division between light and dark mirrors of the first quarter. But the timing differs. The moon now rises later in the night and is most visible in the morning hours. Beyond this point, the illuminated portion continues to shrink. The visible arc becomes thinner. The moon appears lower in the sky before dawn. Its light grows more delicate, yet remains steady. Eventually, the illuminated surface turns almost entirely away from Earth. The visible arc fades. The moon returns to a position near the sun. Visibility drops to nearly nothing. The cycle completes without interruption. Throughout this process, nothing about the moon itself changes. There is no growth, no decline, no renewal. The cycle is continuous, not segmented. Each phase blends into the next without a boundary. The regularity of this pattern made it one of the earliest measures of time. Long before clocks or calendars, the changing moon provided a dependable sequence. It did not require interpretation. It could be seen. Yet the cycle does not align perfectly with human systems. It lasts just over 29 days, This mismatch has always required adjustment. Lunar months drift against solar calendars. The moon does not conform to fixed dates. This independence reinforces the idea: phases are not events, they are viewpoints. The moon does not pass through stages. Earth passes through positions from it. Different portions are visible. Once this relationship is understood, the phases lose any sense of mystery. They become predictable, calm, steady. Each appearance follows naturally from motion already in progress. The moon does not hide and reveal itself deliberately. It does not perform. It moves. Light remains constant. Perspective changes. This perspective is what gives the moon its rhythm. Night after night, the visible surface shifts slightly. The changes are slow enough to follow without effort. They invite observation without demanding it. From the first return of light to its gradual withdrawal, the cycle unfolds without pause. It has no true beginning and no final moment. One phase leads into the next, guided entirely by position and motion. With the pattern established, attention can turn outward. The same gravitational relationship governs motion and phases also reaches beyond appearance, influencing Earth itself in measurable ways. In the earliest period after the moon formed, Earth and the moon were much closer than they are now. The moon filled more of the sky, not as a gentle presence, but as a dominant one. Its gravity reached Earth with greater strength. Shaping conditions would slowly change over time. At distance, the pull between the two bodies was stronger and more immediate. Earth's surface responded, especially where it was most flexible. The oceans, still settling into their basins, began to move in rhythm with the moon's passage. Water rose and fell as Earth turned beneath this influence, not yet in the familiar pattern known today, but in a more forceful version of it. These early tides were powerful. Coastlines were shaped and reshaped repeatedly. Shallow seas advanced and retreated. Energy moved constantly between ocean and land. None of this required intention or direction. It followed naturally from gravity acting across space. As Earth rotated, the raised regions of water did not remain fixed. They were carried forward by the planet's spin. The moon continued on its path. The pattern followed it. With each rotation, Earth lost a small amount of energy. The loss was tiny in any single day, but it never stopped. Over long stretches of time, this constant friction mattered. Earth's rotation began to slow. Days lengthened gradually, stretching from hours once passed more quickly into the familiar length experienced now. The change was so slow, it could never be noticed within a lifetime, but it shaped the planet nonetheless. The energy Earth lost did not disappear. It moved outward into the moon's orbit. As Earth's spin eased, the moon gained distance. Its path widened, step by step, carried outward by the same interaction once made tides stronger. As the moon moved away, its grip on Earth softened. Tides became less extreme. The oceans still rose and fell, but with reduced force. The system adjusted quietly, settling into a more moderate rhythm. This outward drift has continued ever since. Even now, the moon moves away from Earth by a small but measurable amount each year. The process began billions of years ago is still underway, unfolding too slowly to feel, but never stopping. As distance increased, the balance between Earth and moon changed. The moon no longer dominated the sky as it once did. Its phases unfolded more slowly. The night lengthened. The pattern of light and darkness became less abrupt and more familiar. Gravity continued to bind the two bodies together. but with less intensity. The moon's influence remained strong enough to shape oceans, yet gentle enough to allow stability. The system did not break apart, it settled over time. Another effect became important. Earth's axis, tilted relative to its orbit around the Sun, began to benefit from the moon's steady presence. Without stabilizing forces, a planet's tilt can wander, shifting dramatically over long periods. The moon's gravity helped limit these variations. It acted as a counterweight, resisting large swings in orientation. This influence did not lock Earth into a fixed position, but it reduced extremes. Seasons remained broadly consistent rather than chaotic. This consistency mattered. With relatively stable seasons, climate systems could develop patterns persisted long enough for life to adapt. The moon did not create these conditions on its own, but it contributed to the framework allowed them to endure. As life spread across Earth, it encountered tides followed a dependable rhythm. Shorelines flooded and emptied on a regular schedule. Intertidal environments formed, shaped by repeated exposure and retreat. Organisms adapted to cycles could be anticipated rather than endured unpredictably. The moon did not guide this process consciously. It did not respond to life. Its gravity simply continued to act. The same force once shaped molten Earth now shaped living coastlines. Meanwhile, Earth's rotation continued its slow adjustment. Days lengthened further. The difference between ancient timekeeping and modern timekeeping widened. Long before clocks existed, the planet itself was already changing the length of a day. Through all of this, the moon remained present, sometimes bright, sometimes hidden, sometimes dominating the night, sometimes barely noticed. Its appearance shifted, but its influence remained constant. The tides observed today are a quieter version of a much older pattern. They rise and fall predictably. High water follows low water. The schedule drifts with the moon rather than the clock. The ocean still keeps lunar time. When the moon and sun align, their combined pull briefly strengthens the pattern. When they stand at right angles, it softens. These variations are part of the same long story, shaped by geometry rather than intention. What is experienced now is the result of adjustment rather than design. The Earth-Moon system did not arrive fully formed. It settled gradually, shaped by motion, gravity, loss of energy over immense spans of time. The moon's influence reaches Earth whether it is visible or not. Clouds do not block it. Daylight does not diminish it. Gravity continues to act, indifferent to observation. This quiet persistence is what gives the system its character. Nothing happens suddenly. No single tide or year matters on its own. Change accumulates slowly, carried forward by repetition. Seen this way, the moon is not only a light in the sky or a marker of time. It is part of Earth's long physical memory, recorded in oceans, rotation, rhythm. From this shared history, human relationships with the moon eventually emerged. Long before measurements or theories, people lived alongside tides and light followed a pattern older than any culture. That relationship, shaped first by gravity and time, would later be interpreted through observation, calendars, meaning. The physical story came first. Understanding followed much later. As the Earth-Moon system continued to evolve, the moon's influence remained steady, but its effects became more subtle. The most visible changes had already passed. The oceans no longer surged as violently as they once had. The moon no longer dominated the sky. What remained was balance, Earth continued to spin beneath the moon's orbit. The moon continued to circle at a slowly increasing distance. This gradual separation did not weaken the relationship, it refined it. Forces had once been intense became regulated. Extremes softened, patterns settled. One of the most important of these patterns involved how Earth held itself in space. Earth does not spin upright. Its axis is tilted. Tilt governs how sunlight reaches the planet across the year. It determines where seasons form and how strongly they differ. In a system without stabilizing influences, tilt can drift over long periods. A planet's orientation can change dramatically. Sunlight can shift toward the poles or the equator. Seasons can grow extreme or disappear altogether. Climate becomes erratic. The moon quietly limited this outcome. Its gravity resisted large changes in Earth's orientation, not by fixing the axis in place, but by narrowing the range through. It could move. Over time, wide swings became unlikely. Smaller variations remained possible, but the system stayed within bounds. This did not happen suddenly. There was no moment of correction. Instead, the range of motion shrank slowly as the Earth-Moon system matured. Stability emerged not through force, but through persistence. As a result, sunlight followed predictable paths across Earth's surface. Seasons returned year after year in recognizable forms. Differences accumulated gradually rather than arriving without warning. The planet developed memory. Ice advanced and retreated over long cycles. Forests expanded and contracted. Oceans warmed and cooled. These changes were large, but they unfolded within a framework allowed continuity. Earth did not have to relearn its climate each generation. Life adapted within this framework. Organisms responded to cycles could be anticipated. Growth aligned with light. Movement followed temperature. Timing became embedded in behavior. Along coastlines, tides continued to rise and fall. The rhythm was dependable. Exposure and immersion alternated with regularity. Entire ecosystems formed around this repetition. Shaped by the certainty, water would return and retreat again. None of this required awareness. The moon did not guide life. It did not respond to it. The same gravitational interaction once shaped molten Earth continued to act, unchanged by what had emerged beneath it. Meanwhile, Earth's rotation continued to slow. Days lengthened further, almost imperceptibly. Darkness lingered longer. Light stretched out. Biological systems adjusted without noticing the cause. The moon continued its retreat. Each year added a small increment of distance. The change was real, but quiet. The system aged without drawing attention to itself. Through all of this, the moon's visible behavior remained familiar. It continued to grow and shrink in the sky. It rose and set at shifting times. Its cycle repeated with the same steady pace. For much of Earth's history, these patterns passed without record. They were present long before they were observed, long before meaning was assigned to them. They simply occurred. Eventually, humans appeared within this system. They did not arrive to change it. They arrived to live within it. They encountered nights brightened and darkened on a schedule was not fixed, yet never random. They noticed the moon returned in recognizable forms. They saw its light arrived earlier or later, but always in sequence. At first, this was not knowledge, it was familiarity. The moon was seen often enough to be remembered. Its behavior was consistent enough to be expected. Over time, this familiarity turned into recognition. People began to associate certain appearances with certain conditions. A bright moon meant long nights of light. A thin moon meant darkness would return early. These associations did not require measurement. They relied on repetition. The moon taught by doing the same thing again and again. As generations passed, patterns were shared, stories carried timing forward, marks were made to track returns. The moon became a way of dividing experience into portions felt manageable. A cycle could be counted. A span could be anticipated. Time gained shape. This way of marking time did not come from theory. It came from observation. Anyone could look up and know roughly where they stood within the cycle. The moon belonged to no single group. It was available to all. As societies grew more complex, these observations were organized, months were named, calendars formed. Some followed the moon closely, others adjusted lunar cycles to fit the year. The mismatch between lunar cycles and the solar year became apparent. The moon did not divide neatly into seasons. Its rhythm resisted exact alignment. This resistance forced systems of time to bend. Adjustments were made, extra days were added, cycles were corrected. Yet the moon itself did not change. It continued along its path, unconcerned with how it was counted. Despite new systems of timekeeping, the moon retained its influence. Gatherings were timed to its light. Travel followed its rise and set. Nights were shaped by its presence or absence. Navigation drew on its predictability. Orientation relied on its movement, even without instruments. The moon provided reference in darkness. All of this human use rested on a deeper stability. The moon's motion did not falter. Its phases did not skip. Its timing did not accelerate or slow unexpectedly. What people trusted was not symbolism, but reliability. The moon could be counted on because it behaved the same way it always had. Meanwhile, beneath human awareness, the deeper processes continued. Earth's rotation slowed by fractions. The moon drifted outward by centimeters. Axial stability held. The system did not pause for observation. It did not change in response to meaning. Gravity continued to act. Motion continued to unfold. This is what gives the moon its unusual character. It feels ancient because it is. It feels familiar because it changes slowly enough to remain recognizable across generations. The moon seen today is not the moon of Earth's beginning, but it carries history within it. Its rhythm is the product of long adjustment rather than design. What remains now is a system appears calm because it has already passed through its most dramatic stages. The violence of formation is over. The extremes have softened. Balance has taken hold. From this balance, knowledge would eventually grow. Instruments would be built. Telescopes would extend vision. The moon would become an object of study rather than familiarity alone. But long before it was measured or named, the moon had already shaped Earth's time, motion, stability. The story began without witnesses, and it continues, quietly, without pause. Long before the moon became something to explain, it was something to live with. It rose into view without announcement and slipped away just as quietly. Its light arrived on nights when fires burned low. Its absence deepened darkness when clouds cleared. Nothing about it asked for attention, yet it was noticed all the same. Early human lives unfolded beneath this changing sky. Days were shaped by the sun. Nights belonged to whatever light remained. When the moon was present, the world did not disappear after sunset. Shapes could still be seen. Paths could still be followed. Work could continue a little longer. When the moon was absent, night closed in fully, movement slowed, gathering paused, rest arrived earlier. These differences were not measured, but they were felt. Over time, they became familiar. The moon did not need to be understood to be useful. Its return created expectation. Its shape hinted at what kind of night lay ahead. A broad, bright moon suggested long hours of light. A thin arc suggested darkness would return quickly. This familiarity grew through repetition. The moon did the same things again and again. Slowly enough, memory could keep pace. People noticed it did not rise at the same time each night. They noticed it did not keep the same shape for long. They noticed after disappearing, it always came back. Nothing about this required theory. It required only attention over time. The moon taught its patterns by repeating them. As generations passed, these patterns were shared, not in precise terms, but through habit and story. Certain times became associated with certain appearances. Activities aligned with light was expected rather than hoped for. Marks were made to remember returns. Stones were arranged. Notches were carved. These were not attempts to control time. They were ways of staying oriented within it. The moon became a reference because it was visible. It did not need tools. It did not require permission. Anyone who looked up could see it and recognize where they were within its cycle. This shared visibility made lunar time communal. Unlike the sun, it could be hidden by weather or terrain. The moon appeared in darkness when little else could be seen. It became a common signal in the night. As human groups grew and settled, this signaling took on structure. The span between similar appearances became a unit. A cycle gained shape. Time was divided not by numbers, but by recurrence. Months formed from this repetition. They were not counted forward endlessly. They were experienced as loops. One cycle ended where the next began. This way of keeping time did not require precision. It allowed flexibility. The moon's cycle was close enough to human rhythms to feel useful, even if it did not align perfectly with seasons or years. As societies became more complex, this limitation became apparent. The moon's cycle did not divide evenly into the year. Seasons drifted if months were counted without adjustment. This created tension between lunar time and agricultural needs. Different solutions emerged. Some cultures kept time closely aligned to the moon and adjusted seasons as they came. Others modified lunar cycles to keep pace with the sun. Extra days were added. Months were shifted. These adjustments were not imposed on the moon. They were responses to it. The moon continued its cycle unchanged, while human systems bent to accommodate it. Despite these changes, the moon retained its role. Festivals were timed to its fullness. Rituals aligned with its absence. The light it provided still mattered, even as calendars grew more abstract. Navigation also drew on lunar presence. In open landscapes and on water, the moon offered orientation when landmarks vanished. Its rising and setting provided direction. Its path across the sky offered reassurance of position. This use was practical rather than symbolic. The moon was not consulted for meaning. It was used because it could be trusted to behave consistently. As observation deepened, people began to notice finer details. The moon's surface showed patterns. Dark regions stood out against lighter ground. These markings did not change, even as light shifted across them. Different cultures saw different shapes in these patterns. but the patterns themselves remained. The moon carried visible memory. It looked the same to observers, separated by distance and time. Eventually, tools extended vision. Simple lenses brought the moon closer. What had once been a smooth disk revealed texture. Shadows sharpened. Edges gained depth. The moon became not just a marker of time, but an object of curiosity. Its surface no longer seemed abstract. It showed signs of history. Even then, the moon did not lose its earlier role. It continued to rise and set. Its phases continued to unfold. Observation added layers, but did not replace familiarity. Knowledge grew slowly. Ideas were proposed, tested, revised. The moon's motion was charted, its distance estimated, its behavior described more precisely. Yet the foundation remained unchanged. The moon continued to do what it had always done. It moved. It reflected light. It followed a steady path. What changed was perspective. The moon shifted from being simply present to being understood as part of a larger system. Its regularity became something to explain rather than accept. Still, explanation never replaced experience. Even as understanding expanded, the moon remained a companion of nights, visible to anyone who looked up. This layering of familiarity and knowledge gave the moon a unique place in human thought. It was both ordinary and distant, both known and unreachable. As centuries passed, observation became measurement. Instruments refined what eyes had noticed. Patterns became numbers. Cycles became calculations. The moon entered records and tables, but it did not leave the sky. It remained where it had always been, continuing its cycle without regard for how it was tracked. The story of the moon did not change when it was written down. It simply gained another way of being remembered. What began as shared experience slowly became shared knowledge. Yet beneath both, the same physical rhythm continued, steady and indifferent to interpretation. From here, the story moves closer still. The moon would eventually be approached, touched, sampled. What had once been only observed would be visited. But all of rests on a much older relationship. Long before instruments or journeys, the moon had already shaped how time was noticed and night was understood. Its story with Earth had been unfolding for billions of years before it entered human stories at all. What followed was not a change in the moon itself, but a change in how closely humans would begin to look at it. As attention turned more deliberately toward the moon, the way it was seen began to change. Not all at once, not everywhere, but gradually. As observation became more focused and tools became more refined, early attempts to look more closely did not reveal answers so much as questions. Simple lenses magnified the moon's disk, bringing its surface nearer without explaining what it showed. What had once appeared smooth now showed variation. Light and dark were no longer just patterns. They hinted at texture. With improved telescopes, the moon's surface began to resolve into form. Shadows traced edges. Circular depressions repeated across the landscape. Broad, dark plains contrasted with brighter, uneven highlands. The moon no longer looked like a flat light. It looked like a place. These observations challenged earlier assumptions. The moon was not perfectly smooth or uniform. It carried marks. It had a surface shaped by events rather than design. The idea of a flawless celestial body gave way to something more complex. At first, these features were interpreted through familiar frameworks: Dark regions were thought to be seas. Bright areas were seen as land. Names reflected these ideas, even as understanding lagged behind them. Language adapted before explanation caught up. Over time, repeated observation revealed consistency. The same features appeared again and again, unchanged by weather or season. Shadows shifted with light, but the surface itself remained fixed. This stability suggested age. As knowledge deepened, interpretations shifted. The dark plains were not water, but ancient flows of molten rock. The circular depressions were not imperfections, but impact craters formed by collisions long past. The moon was not shaped by slow erosion. It was shaped by sudden events and then preserved. This preservation mattered, without atmosphere or active surface renewal. The moon retained a record Earth could not. Impacts would vanish on Earth, remained visible on the moon for billions of years. The surface became a timeline rather than a landscape. Scientific interest grew steadily. The moon's motion was mapped more precisely. Its distance was measured. Its orbit was refined. Each improvement added detail, but the underlying behavior remained the same. The moon continued to move as it always had. What changed was the confidence with. Its motion could be described. Patterns had once been recognized intuitively were now expressed numerically. Cycles were calculated. Predictions became exact. Still, the moon itself did not respond. It offered no confirmation beyond continuing to behave as expected. The success of these measurements lay in their agreement with observation, not in any change in the moon. As centuries passed, curiosity extended beyond observation. Questions shifted from how the moon appeared to what it was made of. Its surface hinted at composition. Its density suggested internal structure. Its motion implied a shared history with Earth. The moon began to be understood not as an isolated object, but as part of a system. Its behavior made sense only in relation to Earth and Sun together. The story widened. This broader understanding set the stage for a different kind of encounter. The moon was no longer only something to watch. It became something might be reached. The idea of travel did not arise suddenly. It emerged slowly. As knowledge accumulated and technology advanced, each generation added small improvements. No single step closed the distance. When exploration finally became possible, it did not overturn what was already known. It confirmed it. The surface seen through telescopes matched what was found up close. The patterns observed from afar held true. Samples taken from the moon revealed material shaped by heat and impact. Rocks told stories of formation and collision. They carried the same signatures suggested by observation, now held in hand. These samples showed how closely the moon's history was tied to Earth's early past. They reinforced the idea of shared origin. The moon was not a visitor. It was a fragment of Earth's own story. Even with direct contact, the moon did not lose its distance. It remained quiet. It did not change in response to being studied. Its surface stayed still. Its motion continued. Exploration added detail, not drama. The moon became better known, but not less itself. Knowledge filled gaps without altering the rhythm already established. What stood out most was how much had already been learned through simple observation. Centuries of watching had captured the essential behavior of the system. Instruments refined understanding, but they did not replace it. The moon remained a steady reference, even as methods of study grew more complex. It continued to rise and set. Its phases continued to unfold. Its influence on Earth continued without interruption. Scientific understanding deepened, but the experience of the moon remained accessible. Anyone could still look up and see the same patterns had been observed for generations. The moon became both a subject of study and a familiar presence. These two roles did not compete. They coexisted. From here, the story does not move toward resolution, but toward perspective. The moon is known well enough to be described accurately, yet distant enough to remain unchanged by knowledge. It continues along its path, carrying with it a surface records time and emotion, reflects deep history. With so much already known, the moon gradually took on a different role. It became less a mystery to solve and more a reference point to return to. Its behavior was steady enough to serve as a baseline, a constant against it other changes could be measured. Because the moon lacks an atmosphere and active surface renewal, it preserves conditions are rare elsewhere. Its surface does not erase itself. Marks remain. Layers of history stay exposed. For scientists, this made the moon a kind of archive. Holding records of events had long vanished from Earth. Some of the most revealing places were those never see sunlight. Near the moon's poles, certain craters remain permanently shadowed. Their walls block the sun completely. Inside them, temperatures remain extremely low, unchanged for billions of years. In these shadowed regions, material can survive would not last elsewhere. Water ice, delivered by impacts long ago, remains trapped. It does not melt or evaporate. It stays where it fell, preserved by darkness and cold. This discovery did not transform the moon's appearance. Nothing changed on the surface could be seen from Earth. Instead, it changed understanding. The moon was no longer just dry and inert. It contained pockets of preserved material, quietly held in place. These regions highlighted the moon's role as a keeper of deep time. Processes erase evidence on Earth have no power there. The absence of change became valuable in itself. Elsewhere on the surface, the same stillness applied. Craters remained sharp. Plains stayed smooth. The record of impacts stretched back to the early solar system. Each mark represented an event shaped not only the moon, but the space around it. By studying this record, scientists gained insight into Earth's past as well. Many of the impacts recorded on the moon would have struck Earth too. On Earth, erosion and tectonics removed the evidence. On the moon, it remained. The moon became a way to look backward beyond Earth's own memory. Its surface filled in gaps could not be recovered elsewhere. It offered context rather than narrative, evidence rather than explanation. At the same time, the moon's future continued to unfold quietly. The outward drift did not stop. Each year, distance increased by a small amount. The change remained imperceptible in daily life, but it continued all the same. As distance increases, tides will continue to soften. Earth's rotation will continue to slow. Days will lengthen further. These changes will take place over timescales far longer than human history. The moon will remain visible. Its phases will continue. Its timing will still drift through the night. The pattern will feel familiar long after its deeper parameters have shifted. Nothing about this future requires intervention. The system is stable. It has been stable for a long time. The same forces shaped it in the past continue to operate without pause. In this sense, the moon does not move toward an ending. It moves forward within a range has already been established. Its story is not one of progress or decline, but of persistence. For humans, This persistence has always been part of the experience. The moon has been present across generations, cultures, lifetimes. It has outlasted systems built to track it. It has remained while languages and tools have changed. Even now, with detailed maps and measurements, the moon still occupies the same role in the sky. It rises, it sets, it changes shape slowly. It does not require explanation to be noticed. The value of the moon is not limited to what it teaches scientifically. It also offers continuity. It behaves today as it did yesterday, much as it did long ago. This reliability creates a sense of connection across time. The moon does not mark events, it marks passage. It does not announce change, it carries it forward quietly. From formation to orbit, from gravity to light, from tides to timekeeping. The moon's influence has never depended on attention. It has shaped conditions simply by being present. What remains now is not mystery, but familiarity grounded in understanding. The moon is known well enough to be trusted, distant enough to remain unchanged by trust. Because of this, the moon remains useful not because it is dramatic, but because it is stable. Its surface changes slowly, its motion can be relied upon, its record stays visible. These qualities are what allow it to continue serving as a reference long after more active systems have overwritten their past. After spending time with the moon's origin, motion, light, influence, it becomes possible to notice how these elements exist together rather than separately. The moon does not move through stages in sequence. Motion, illumination, gravity operate at the same time, every day. The moon is always traveling along its orbit. That movement continues whether the moon is visible or hidden by daylight. Position changes continuously, even when appearance does not. At the same time, sunlight reaches the moon without interruption. One half of the surface remains illuminated at all times. This does not vary. The portion can be seen from Earth changes as the viewing angle shifts. Because of this, the moon's appearance can change dramatically, while the surface itself remains unchanged. A narrow crescent and a full disk are views of the same object under the same light, separated only by position. The timing of the moon follows directly from this motion. Each night, the moon rises later than it did before. The shift is small from one evening to the next, but it accumulates over the course of a month. The moon moves through every part of the night. Sometimes it appears soon after sunset. Other times it rises near midnight or just before dawn. This is not an added feature. It is the visible result of orbital motion combined with Earth's rotation. Earth's rotation continues underneath the moon's path. The moon does not replace this movement. The two motions overlap. What appears in the sky is shaped by both at once, because Earth is tilted and the moon's orbit is inclined. The moon's path across the sky changes over the year. Some months it climbs higher, other months it remains closer to the horizon. The pattern repeats with variation rather than exact duplication. The moon's orientation also shifts slightly as it moves. Over time, this exposes different portions of the surface near the edges. These changes are small, but they accumulate, allowing more than half of the surface to be seen over many months. Distance varies as well. The moon's orbit is not perfectly circular. When it is closer, it appears marginally larger and brighter. When it is farther away, it appears slightly smaller and dimmer. These differences repeat without disrupting the overall cycle. Light interacts with Earth's atmosphere as the moon rises and sets. When the moon is low, its light passes through more air. Shorter wavelengths scatter more strongly, shifting color toward warmer tones. As the moon climbs higher, this filtering decreases. The apparent size of the moon also changes with position in the sky. Near the horizon, familiar objects provide scale. Without those references overhead, the same moon appears smaller. The physical size does not change. While these visual effects unfold above, gravity continues to act below. The moon's pull affects Earth's oceans continuously. Water responds whether the moon is visible or not. Tidal patterns follow lunar timing rather than the clock. High water arrives later each day, matching the moon's delayed rise. Over weeks, the timing drifts. Over months, it repeats. The connection remains consistent. Over longer spans, gravity alters rotation and distance. Earth's spin slows gradually. The moon moves outward. These changes proceed at rates cannot be sensed directly, but they shape the system over time. What is called the lunar cycle is not a sequence of events. It is a repeating geometry. The moon does not begin or finish a process. It occupies positions return. A full moon indicates alignment rather than completion. A new moon indicates orientation rather than absence. The illuminated surface remains. The viewing angle changes. This is why the moon can be encountered at any point without missing context. There is no starting position must be observed first. The system is already operating. Recognition of the moon does not depend on explanation. Repeated exposure is enough. The same patterns return often enough to become familiar. Over time, these patterns form memory, not in words or measurements, but in expectation. Certain shapes correspond to certain nights. Certain timings feel familiar. These impressions build without instruction. They result from consistency, even when the moon is hidden by cloud or daylight. Its position continues to change. The system does not pause. Motion and gravity continue independently of visibility. This allows the moon to serve multiple roles at once. It provides light, influences tides, marks time, preserves physical history, all through the same set of motions. No single description captures all of this. The moon is not defined by one behavior. Its presence is the result of several processes operating together. Seen this way, the moon does not need to be followed step by step. It can be held as a complete system, with each part reinforcing the others. Motion determines timing. Light determines appearance. Gravity determines influence. These relationships remain stable. That stability is what allows the moon to be returned to again and again. From any point in its cycle, once the moon is understood as a system rather than a sequence, it begins to take on a different kind of presence across time, not across a month or a year, but across a lifetime. The moon seen in childhood is the same moon seen decades later. Its size does not change. Its motion does not speed up or slow down in any way can be felt. What changes is the way it is encountered. Early on, the moon is noticed without context. It is simply there, sometimes bright, sometimes faint, sometimes present at night, sometimes missing altogether. Its changes are observed before they are understood. Over time, patterns begin to register. The moon does not appear at random. Certain shapes return. Certain timings repeat. The sequence becomes familiar long before it is named. As years pass, This familiarity deepens. The moon is seen from different places. It rises behind different buildings. It crosses different landscapes. The object remains the same, but the setting changes. Some nights it appears low and colored by the air. Other nights it stands high and pale. These differences become part of memory, even if they are never analyzed. The moon also becomes associated with routine. It is present during evening walks, late drives, early mornings. Its position begins to hint at the hour without the need to check a clock. A bright moon high in the sky suggests one kind of night. A thin moon near the horizon suggests another. These associations form gradually through repetition rather than instruction. Across decades, the moon continues to return at different points in life. It appears during periods of change and periods of stability. Its cycle does not adjust to circumstance. It proceeds at the same pace regardless. Because of this, the moon becomes a reference across memory. A moon seen years ago is recognizable when seen again. The interval does not matter. The pattern closes the distance. This continuity does not rely on precision. One does not need to remember exact dates or phases. Recognition is enough. The moon does not require accuracy to be familiar. The slow pace of change contributes to this effect. The moon does not shift abruptly. Differences accumulate gently. Attention is not demanded. It is optional. Even long absences do not break the pattern. Someone who has not looked up for months encounters the same system upon return. Nothing has been missed. The cycle has continued without pause. The moon also spans generations in this way. What one person sees, others see too. The same surface markings, the same timing, the same cycle length. The object does not personalize itself. Stories told about the moon may change. Explanations may differ. Cultural meanings may shift. The moon itself remains consistent. This consistency allows shared reference. Different people, separated by age or experience, can look at the same moon and recognize it as the same object. The moon therefore exists both in personal memory and outside it. It is encountered privately, yet remains unchanged by those encounters. Across a lifetime, understanding may increase. The reasons for phases, timing, motion may become clear. This knowledge does not replace the experience, it layers onto it. Knowing why the moon rises later does not stop it from being noticed. Knowing why it changes shape does not make those changes less visible. The moon does not become smaller once it is explained. It does not lose presence. Explanation adds context, not distance, at the same time. The moon does not adapt to understanding. It does not behave differently once known. It continues according to the same physical constraints. This independence is part of what makes it reliable. The moon does not require interpretation to function. It does not respond to expectation. Across decades, its role remains consistent. It marks time without counting it. It provides light without generating it. It influences Earth without being aware of it. The moon is present during ordinary nights far more often than during remarkable ones. Most encounters are unremarkable. This is what allows it to remain familiar rather than exceptional. Its predictability does not make it dull. It makes it dependable. Familiarity builds not from novelty, but from repetition. As years pass, the moon becomes part of the background of experience. It is noticed without effort and remembered without emphasis. This long exposure shapes perception. The moon feels steady because it is. Its behavior aligns with memory, often enough to feel continuous. The system does not change its pace to match a human lifetime. It moves at its own speed. That speed happens to be slow enough to remain recognizable across decades. This alignment between human memory and lunar motion is not designed. It is a coincidence of scale. The moon exists at a pace can be lived alongside. Not rushed, not frozen, simply ongoing. Because of this, the moon does not feel new or old. It feels present. It occupies time without drawing attention to itself. Across a lifetime, it does not accumulate meaning through intention. Meaning gathers because the same object is encountered repeatedly under different conditions. The moon does not tell a story on its own. The story forms through continued exposure. The moon seen now is connected to every moon seen before it, not by memory alone, but by uninterrupted motion. That continuity does not lead toward a conclusion. It holds steady. From here, what remains is not another explanation, but a final narrowing of focus. The moon can be held in mind as it is now, complete and ongoing, without needing to move forward or back. On any given night, the moon occupies one specific place along its orbit. That place is never permanent. By the following night, it will have moved on. The change is small, but it never stops. Earth turns beneath this motion. As it does, the moon comes into view or slips away. Sometimes it appears early in the evening. Other times it does not rise until the night is already deep. Over time, this shifting becomes familiar. Sunlight continues to reach the moon from the same direction it always has. One side remains lit. That does not change. What changes is how Earth's rotation lines up with light. Some nights, only a narrow edge of illumination is visible. Other nights, most of the surface faces Earth. These differences do not arrive suddenly. They unfold as the moon advances along its path. While this happens, the moon's distance changes slightly. Some months it is closer, other months it is farther away. The difference is not dramatic, but it affects how bright the moon appears and how large it looks in the sky. The path the moon follows across the sky also changes with time of year. In some seasons, it climbs higher. In others, it remains closer to the horizon. These changes repeat, but not in exact alignment with the calendar. Light behaves differently depending on where the moon appears. When it is low, its light passes through more air, colors warm. When it rises higher, the light clears. These effects come and go as position changes. Below this, the oceans respond. Water rises and falls according to the moon's position. The timing shifts gradually, following the same delayed rhythm as moonrise. Coastlines experience this movement without interruption. These responses do not depend on visibility. Tides continue whether the moon is seen or hidden. Clouds and daylight make no difference to gravity. Earth's rotation continues to slow by an amount too small to feel. The moon continues to move outward by a distance too small to notice. These changes remain present, even though they do not announce themselves. Nothing in this system requires adjustment. Each part follows from the same constraints have applied for a very long time. Motion leads to timing. Timing leads to appearance. Gravity leads to influence. Because of this, the moon does not need to be checked or tracked to remain reliable. It does not drift away from expectation. It follows the same sequence it always has. This is why the moon can disappear from attention for long stretches and still feel familiar when noticed again. Its behavior has not changed in the meantime. There is no need to know where the moon is in its cycle to recognize it. A glance is enough to place it roughly in time. The pattern has repeated often enough to register without effort. At this scale, the moon is not moving toward a destination. It is continuing along a path closes and opens repeatedly. There is no final position to reach. Seen this way, the moon does not need to be summarized. It does not need to be held together by explanation. The system holds itself together. At the present moment, the moon is already moving into its next position. The conditions shape it remain the same as they were before. What comes after this is not a new phase of the moon, but simply the continuation of the same arrangement. On one evening, the moon appears shortly after sunset. It hangs low in the sky, pale and partial, easy to overlook at first. As daylight fades, its light becomes clearer. It does not brighten suddenly. It simply remains visible while everything else darkens. For a while, it stays close to the horizon. Its light passes through a long stretch of air, softening color and contrast. Shadows on the ground remain faint. The moon feels present without taking over the night. Later, it slips out of view. The night continues without it. Darkness deepens. The sky rearranges itself around stars instead. The following evening, the moon returns a little later. The difference is small, but noticeable. It rises after the sky has already darkened. Its light now feels more distinct against the background. This time, it stays longer. It climbs higher before setting. Its path crosses more of the sky. The night is divided differently around it. On another night, the moon does not appear until well after evening has passed. Darkness has already settled. The landscape has adjusted. When the moon finally rises, it feels like an arrival rather than a companion. Its light spreads slowly across surfaces have already cooled. Shadows form more clearly. Details emerge where there were none before. The night changes character without changing pace. As nights continue, the moon begins to occupy the middle hours. It rises near midnight. It reaches its highest point while most of the world is quiet. By the time morning approaches, it is already descending. During these nights, the moon belongs less to evening and more to early morning. It is seen during brief awakenings or at the edge of dawn. Its light mixes with the first hints of daylight before fading again. Eventually, the moon appears just before sunrise. It hangs low in the brightening sky, faint but distinct. Its presence is brief. It does not linger. It slips away as the sun takes over. For a time, the moon is absent at night altogether. It travels through the sky during daylight hours instead. Its cycle continues without display. Then, gradually, it returns. A thin edge of light appears low in the evening sky. It is easy to miss. It does not illuminate much. It simply marks a return. Night by night, light grows. The moon stays a little longer. It rises a little earlier. The night shifts around it again. This sequence does not require attention to be followed. It can be noticed in fragments. One night here, another there. The pattern holds even when not watched closely. Over several weeks, the moon passes through every arrangement of presence and absence. It arrives early. It arrives late. It stays all night. It leaves quickly. Each version feels distinct, yet familiar. Nothing about this sequence is abrupt. Changes accumulate gently. The night never resets. It adjusts. While this is happening, the moon's position among the stars changes as well. It drifts eastward, moving into new backgrounds. Familiar constellations shift around it. The moon does not stay anchored to one section of the sky. Some nights it passes close to bright stars. Other nights it moves through emptier regions. These encounters do not alter the moon. They change how it is framed. Clouds add another layer. Some nights the moon is fully visible. Other nights it appears and disappears. Light breaks through gaps and fades again. The moon's timing continues regardless. Weather does not interrupt the cycle. It only affects visibility. The sequence proceeds above cloud cover as it does in clear skies. Over time, this movement through nights becomes predictable without being memorized. One does not need to track dates. The moon's presence hints at where it is within its rhythm. A moon seen early in the evening suggests one part of the sequence. A moon seen near dawn suggests another. These impressions form through repetition rather than calculation. The moon also changes how nights feel. A bright night feels open. A dark night feels enclosed. These differences influence movement and rest without instruction. Across weeks, the moon reshapes the night repeatedly. It redistributes light. It rearranges shadow. It alters when darkness feels complete and when it feels interrupted. These changes occur whether or not they are noticed. The moon does not depend on awareness to follow its path. The night continues to reorganize itself around it. Seen across consecutive nights, the moon does not tell a single story. It traces a pattern of variation. Presence shifts, timing shifts, light shifts. What remains constant is the pace. Each night advances the sequence by a similar amount. The rhythm holds. There is no special night marks completion. There is no night where the sequence ends. One arrangement gives way to the next, then returns. This is how the moon exists in lived time, not as a diagram or a concept, but as a shifting presence moves through ordinary nights. The pattern does not demand to be followed from beginning to end. It can be entered at any point. It will still be moving by the time it returns again, even when missed entirely. The moon returns to a familiar place within a few weeks. The sequence closes on itself without instruction. Across seasons, this nightly movement repeats against different skies. The arc the moon follows changes. The hours it occupies adjust. The underlying rhythm remains. This repetition without sameness is what allows the moon to be lived alongside rather than studied continuously. It changes enough to be noticed and remains steady enough to be trusted. Some nights pass without the moon being noticed at all. It may be behind cloud, or low on the horizon, or simply outside the small part of the sky happens to be seen. The night still unfolds in the same way. Time still moves forward. The moon continues along its orbit, regardless of whether it is looked at. When it does appear again, it does not feel like a return from absence. It feels as if it has been there the whole time, because it has. The cycle has continued in the background, changing position night by night, even while attention was elsewhere. There are evenings when the moon is already present in the sky before darkness is complete. It sits in pale daylight, visible but subdued. As the sky dims, it becomes clearer without changing. The difference comes from the background, not the moon. On other nights it arrives late, when the world has already settled. Darkness has already taken hold. When moonlight appears, it does not replace night. it sits within it, adding visibility without removing shadow. Sometimes the moon is bright enough to cast distinct shapes. Edges become clearer. Trees and buildings develop defined outlines. Surfaces were indistinct gain form. The change is quiet, but it alters how space is perceived. On darker nights, the world compresses. Distances feel shorter. Movement slows, not because the body moves differently, but because surroundings offer fewer points of reference. The absence of moonlight changes the night's texture. These differences occur without planning. They are not arranged for convenience. They follow from position and timing. The moon's schedule is independent of human routines. Over weeks, the moon's timing shifts through every hour of night. It appears and disappears in different parts of the evening and morning. This drift can be lived through without being tracked. The pattern makes itself known simply through recurrence. The same is true of its light. It expands and narrows gradually. There are no sharp borders between one state and the next. Night by night, the visible portion changes by a small amount. The effect is cumulative. Even when the moon is bright, it does not behave like daylight. Colors remain muted. Contrast remains softer. The world does not become fully clear. The moon's light allows visibility while leaving darkness intact. The sky itself responds to this light. A bright moon reduces the visibility of faint stars. A darker moon allows them to appear in greater numbers. The sky changes in depth without changing in structure. At times, the moon passes through regions of the sky dense with stars. At other times it moves through emptier stretches. It does not pause for these backgrounds. It continues forward, changing its setting as it goes. Season by season, its path across the sky shifts. The same phase can appear at a different height and follow a different arc. The moon's movement through nights repeats, but the sky it crosses is not the same. Cloud, haze, air quality alter the way moonlight appears. Some nights it looks crisp and clear. Other nights it is softened and scattered. The source remains the same. The space between alters the result. Near the horizon, the moon's light can warm in color. Higher up, it clears. These shifts do not announce themselves. They come and go with position. There are also nights when the moon appears larger near the horizon than it does overhead. The physical size does not change. The effect depends on surrounding objects and the way the scene is framed. It is part of perception rather than physics. Over time, these familiar variations accumulate into recognition. One does not need to label them. One simply learns how the moon behaves in the same way one learns the pattern of a tide or the length of a season. The ocean continues its response in the background. Water rises and falls on a schedule, drifts through the day. Coastlines experience this without needing to be watched. The timing continues even far from shore, further inland. These effects are felt less directly, but they are still present. Gravity does not weaken with attention. It applies its influence everywhere on Earth, over very long spans. Earth's rotation continues its slow change. The moon continues its gradual retreat. These processes are not part of everyday experience, but they remain active beneath it. What is visible, what is felt, what is measurable occur at different scales, yet they belong to the same system. A night's brightness, a month's timing, a geological shift in distance are connected, even though they cannot be experienced in the same way. This connection does not need to be held in mind. It remains true without being considered. The moon's role does not depend on understanding. There are nights when the moon is watched closely, nights when it is not. There are stretches of life when it is remembered, stretches when it passes unnoticed. The system remains unchanged by these differences. In practical terms, this means the moon can be returned to at any time. The pattern does not need to be restarted. It is always in progress. A glance can capture where it sits in the sky. Another glance a week later shows a different arrangement. Another a month later returns it to a familiar position. The system closes and opens again. This repeating motion creates a steady framework for night itself. Darkness arrives at predictable hours. The moon's light appears and departs on a slower schedule layered over daily cycle. Together, they create variation without disorder. The moon's presence does not define the night, but it modifies it. It changes what can be seen. It changes how long light remains. It shifts when the darkest hours feel complete. Yet night does not depend on it. Nights continue when the moon is absent. Moonlight returns when the cycle brings it back. Neither state breaks the rhythm. The moon is therefore part of the environment, in a way is both ordinary and durable. It participates without interruption. It continues without requiring a place in thought. This is the condition remains at the end of all description. The moon is still moving. Light still reaches it. Gravity still reaches Earth. Nights still pass, shaped slightly differently from one to the next. The moon does not adjust its pace as attention shifts. Nights continue to pass in sequence, each one slightly different from the last. Some are shaped by moonlight, others are not. The alternation remains steady. Across these nights, the moon continues to change where it appears and how long it stays. These changes do not require tracking. They make themselves known through repetition alone. The sky remains larger than any single object within it. Stars appear and fade depending on light. Clouds pass, air clears or thickens. The moon moves through these conditions without reacting to them. At times, the moon is noticed only briefly, a glance through a window, a moment outdoors. At other times, it is not noticed at all. Neither changes the sequence. The moon's movement through space continues regardless. Its position relative to Earth and Sun shifts continuously. Light reaches its surface without interruption. Gravity reaches Earth without pause. Even when the moon is not visible at night, its influence remains present. Oceans continue their timing. Rotation continues its slow adjustment. Distance continues to change by small amounts cannot be felt. Thank you for listening to the Sleepy Mind channel. I hope you have enjoyed spending time learning about this living system.